Ladies and gentlemen, boys and girls, children of most ages, we are going to work on these division problems. We're going to look at using partial products. A lot of you have been taught the standard algorithm, but really the standard algorithm's a lot more work when you're doing things like 38. What I normally do if we're doing the standard algorithm, if we were doing this problem, I would have you write down all of the multiples of 38, 1 through 9, just because that's the way I go. Now, the first thing you're going to look at, for those paying attention, when you're doing a division problem, like this division problem here, is you need to identify where your first number is going. Where your numbers go in the quotient is important. Because once we start moving into decimals, if you don't put your numbers in the quotient in the correct place, then we're going to have a big problem as far as getting it right. So in this one, 4 doesn't go into 2. 4 does going to go into 23. You're going to have a 2-digit answer. So you're going to have a number in the ones place and a number in the tens place. It's very important to figure out where the numbers are placed when you're doing division. In this problem, 38 doesn't go into 9, but 38 does go into 90. So you're going to have a 3-digit answer. And I just made these problems up, so there's probably a good chance there's remainders. This one, 13 doesn't go into 1, but 13 goes into 18. You're going to have a 1, 2, 3, 4-digit answer. So the first thing that's very, very important is you find where your first number goes in your quotient. Because as we move on to decimals, it's going to be a problem if you put it in the wrong place. All right, so let's start with this one. Let's see, I can do 4 times 10. What would 4 times 10 give me? 40. Well, that's not really close. But what would 4 times 20 give me? 80. So I'm going to do 4 times 20, which means I put my 20 off to the side here. I'm going to subtract whatever 4 times 20 is. And some of y'all need practice subtracting, I'm just saying. 6 minus 0 is 6. 23, 22, 21, 20, 19, 18, 17, 16, 15. So that would be 8, or that'd be 15. So now I have 156. I can go another 20, because another 20 would give me 80. So I'm going to go another 20. I'll put those off to the side here. Another 20 would give me 80. And I subtract that. I get 6. 15 subtract 8 is not 13. How can it be 13? 7. Okay, now I got 76. Now, I can't use 20, so I've got to use smaller than 20, right? And on our number talks, we've been practicing multiplying by things with zeros. So if I say 4 times, 10 is what? 40. So if I said 4 times 12 is what?
36, 48, no, 60, 48.
48. So once we get down and we know it's down to where we can use what we know in our multiplication chart. But let's use 4 times 10. Then I'd have 40, subtract, I get 36. Now we know 4 goes into 36 how many times? 9. Good, so this does not have a remainder. Absolutely amazing. All right, so my answer, I just add up what I did here, 20, 40, 59. So my answer here is 59. Real important. The 5 goes in the 10's place, the 9 goes in the 1's place. Muy importante. Now, I always go back, at least I do, because I care about my grades. And if you were getting an assignment that said 1-digit divisors or any division problem, and you didn't do well on it. So let's say today's one-digit divisor problem, you don't do well on it. You're going to have to do it again, but also you're going to have to check it by multiplying my quotient times my divisor. So if you get a failing grade on the one-digit divisors, I'm just saying you're going to end up having to do twice as much work as normal. 4 times 9 is 36. 5 times 4 is 20. Plus 3 is 23. So we did get that one correct. And as I work through them, I'm going to check them because I want you to get in the habit of seeing it. Now, you'll be in the habit of seeing it. Doing it's another question, whether you'll take the time to get a good grade. I'm just saying. All right, let's do the next problem, and we're going to get oozy here. Now, I know it goes into 90. I mean, if I put 38 into 90, it would probably go twice, but I don't do all that. So 38 times 10 would be what? 380. What about 38 times 100? 3,800. What if I could do 200? We'll do 100.
No, do 200.
Do you know what 200 is off the top of your head?
I do.
What is it, Nick?
7,600.
7,600?
Yeah.
So we're doing 200?
Yeah.
And so we'll do 7,600. We're going to subtract. I get 6, I get 2, 4, 14? Is that right?
Yeah, you can't subtract anymore.
Okay.
Yeah, it's 14.
All right. Can I use 10? Yeah. Can I use 20?
No. Yes.
Yes?
Yeah.
So what's 38 times 20? What was 38 times 10?
380.
380. So what would 78 times 20 be?
760.
760. So let's do 20. We'll get 760. We'll get 6. Change this to 41. Oh, 40. I'm sorry. 12. That's 6. 7. Because 14 minus 7 is 7. Now what do you want to do, Ava? I don't know yet, but that has nothing to do with what we're doing. Now what do you want to do, Maxwell?
We can do the same thing I just did again.
Oh, we can. And how do you know we can? Because 20 times 38 is what?
20 times 38 is 760.
760. And remember, we have to keep going until what I have left is smaller than my quotient. Brantley?
Are we just going to put a remainder or are we going to do decimal?
We're going to put a remainder right now. We'll put a remainder right now. Now, let's see, 220, 240, remainder 6. Is that going to work? 200, 220, 240, remainder 6. All right, now in order to check it, I'm going to have to multiply 240 times 38, and then whatever I get, I'm going to have to add 6 to it. So 8 times 0 is 0. We've got something wrong here. I can tell right away we got something wrong. How can I tell right away? Oh, no, never mind, because we're going to add 6. Never mind. All right, brain's not functioning quite yet. As you can tell, then I drove all the way to work without any of my stuff and had to go home. 8 times 4 is? 32. 8 times 2 is?
16.
Plus 3.
19.
I'm moving to my 1's place, or my 10's place, so I need to Put a 0 in the ones. 3 times 0 is 0. 3 times 4.
6.
3 times 2.
7.
Plus 1.
7.
Alright, so I get 0, I get 2, 9, 10, 11, 7, 8, 9. Then I have to add my remainder. I get 6, 2, 1, 9. So we did something wrong somewhere, huh?
I'm pretty sure I know.
Yeah, I did get my hundreds wrong.
I'm pretty sure I know.
Where?
On the when you did 1,426 160. Pretty sure that equals 600.
Yeah, that 4 should be a 3. I think that 4 should be.
This 4 should be a 3?
I think so.
Yeah, you added. Yeah. You crossed it out and you put a 4 above it.
Yeah, that should.
Oh yeah, there should be a 3.
Oh, it should be a 3. Alright, so that's why we check them with multiplication. So they are absolutely right. This 4 should be a 3, which changes my 100 space, which is what we have wrong here.
This 7 should be a 6.
Yeah, so as we go down, it's just going to keep changing things. Once it's a 6, I can't divide by 20 again. So that's why it's important to check them. I'm not going to fix it because I'm losing my voice and I'm lazy.
Why are you losing your voice?
I don't know,
Yes, you
because I have Ebola. All right, so we've decided my 13 goes into 8 or 18. So I'm going to have a 4-digit quotient. What do we want to start with?
let's do 100.
100?
Yeah.
No?
Yeah, 100.
1,000?
Yeah, 1,000. That'd be 13,000.
So we're doing 1,000 here. So 13 times 1,000 is what?
13,000.
Now we subtract. We got 1, 2, 9. So now we got 5,921. As long as I'm doing my math correctly, hopefully you're checking me.
Yes, we can do like 100.
Now we want to do what?
I think we can do like 100.
Now we can do 100.
150.
No.
Let's. So what's 13 times 100?
1,300. 1,300.
1, 2, 6, 4. So as long as I'm doing my math correctly. So what would be 200? 200?
2,600.
2,600?
Oh, we could have done that before.
Okay. What else can we do?
I guess we can do 100 again. 100.
We can do 100 again.
Yeah.
It's 1,300.
Are you 1,000?
Did I do my? Oh, that's a 2. Sorry. 1, 2, 721. Is that right?
We could do 100.
No.
We could do 10.
Yeah, that's
13. 20 minus
Yeah, we
13.
can do 10. Could we do 10? I think we could do 10. Yeah, 10.
No,
10.
let's do
10. 10.
What would 20 be? If 10 is a 130, what would 20 be?
260.
260?
We can do like
260.
We
Okay.
could do 4.
What's 4 then?
40.
40 is going to give me 2 zeros
It would
behind
be
this.
2. It would be.
So let's do 20.
Yeah.
20 is what? Did we say?
260.
260. Let's see. 1, 6, 12, 6, 461.
30.
We'll do 30. What's 30 times 13?
390.
390. 30, 390. Get 1, 5, so 6, 7. And then
Yeah, let's do 10.
I can't do 10. Probably.
5. Probably have to go by 3.
Now we're gonna have to see here. 13 times 5, 18, 5, 65.
Yeah, 5. Yeah. 5.
So 5, 10, 65. We've got 71 minus 65, which gives us 6. So we're going to have 1,000, 100, 300, 400, 20, 55. So 1,455
Now let's see if we did
with
the
a
math
remainder of
wrong.
6.
Okay.
85.
Now, obviously, because my brain isn't working as well as it should today, we're going to check it. Because we like good grades and we cannot lie. We got 1, 4, 5, 15, 16, 13. Oh, did I get that part right?
3 times 4? Wait, did you do 3 times 4?
Yeah, but I had to carry from 3
Okay,
times
so
4.
you still have to do the bottom number.
Okay?
Oh, yeah.
Now, look, I don't have to think when I'm doing the bottom number really if it's a 1.
Yeah.
Once I put my 0 there, I'm going to have 1, 4, 5, 5. Because it's multiplying by 1. So you get 5, 11, 8, 9, 8, 9.
Oh, we did something wrong.
Add the 6.
Oh yeah. Okay, you gotta add that. Yay! You gotta add that. Wow. You got it right.
Yeah, we did. Yes,
So that is the partial product method. You're all going to do it differently. I mean, because some people could look at this and figure out, well, if 100 is 1,300, and maybe figure out what 500 would be. So, and you may end up having to do some extra math on the side. I could do 500 times 13.
which equals a number.
A number.
Yeah, a number. It equals 85.
So 6,500 if I did that math correct. So you can use different numbers. It's not have to be all the same. Boom, shakalaka, peace out, God bless, love you, do something today, save the bees. Please subscribe.